All right, this is the new packet on right triangle review. And we're doing these out of order. It's the order that's on the little pink sheet is the order I'm gonna go, kind of, sort of, not really. Okay, I'm a liar. I don't know, what does that say? Okay, thanks. Is it all done? Yeah, you can throw it in the bin, that would be great. Yep, this is what I wanna do. Okay, 4B. I am not going to go over any of this. It's all stuff you should already know. Honestly, I am going to just do a couple of quick examples, okay? This slide I did put up here. Make sure that somewhere you have down that the 45, 45, 90, and 30, 60, 90 stuff. Do you need me to give you a second to write those down? Okay, 45, 45, 90. You can use, oh, that's a horrible triangle. X, and x square roots of 2. It is also okay to use 1, 1, and square root of 2. It is also okay to use square root of 2, square root of 2, and 2. It's the same thing. All right, all of those are 45, 45, 90. The 30, 60, 90, the short leg is x, the long leg is x square roots of 3, and the hypotenuse is 2x. Or you can say across from the 60 goes the square root of 3, across from the 30 goes 1, the hypotenuse is 2. Eventually we'll talk about the unit circle where we shorten that hypotenuse to 1, which makes this one square root of 3 over 2 and this one 1 over 2. Okay, you don't need to know all those, just know one of them. All right. On worksheet 5A. Everybody ready? You don't have to do anything on 1 through 4. Number 7, 5 is assigned. I am going to do number 7 very quickly. It says, the directions say find all the trig functions, so I need to find this missing side over here. So I'm going to quickly do Pythagorean theorem. This is 121, this is 64. If I'm going to call that anything, I should probably call it y, because it's up and down, but it really doesn't matter. 121 minus 64, anybody helping me out? 57 maybe? Okay, so y is the square root of 57, which does not simplify. I don't think your example's quite as ugly as mine, but that's okay. Or the one you have assigned, I mean, is quite as ugly as this one. Now we need all the trig functions. So we have sine, which is opposite over hypotenuse, square root of 57 over 11. Cosine is what?
8 over 11.
Okay, tangent is opposite over adjacent. All right, then what's it called when we flip sine over?
Cosecant.
So we get 11 over the square root of 57, which if we do that whole ugly rationalization thing, and I don't care if you don't show it, becomes 11 square roots of 57 over 57. Is everybody okay with that process? Can I just go straight to that? The flip of cosine is secant, so that one's just 11 over 8. And the flip of tangent is cotangent. 8 over the square root of 57 rationalizes to 8 square roots of 57 over 57. Okay, you have to do number 5. Does that seem doable? What? Another sheet of paper is fine. You don't have to do them on here. That's for sure. All right, the next little section. I'm on the right page, guys. Okay, this is worksheet. I don't have the number up here. I'm still on worksheet 5A, right? Okay, you are assigned number 9. I'm going to do number 10 real quick. just draw a right triangle, guys. Mark the sine opposite and hypotenuse. Now you have to find all the rest of the trig functions. So do Pythagorean theorem here. Nine minus 4 square root of 5. I kind of did that funky, but did everybody figure out where I got square root of 5? They already gave us the sine is 2/3. So the cosine would be what? Give me a shout out, guys. Cosine. Square root of 5 over 3. Yep. Tangent?
2 over square root of 5, which simplifies to 2 square roots of 5 over 5.
Whoa, I don't know what that is. It's a very curly 2. Okay. We have to do the other 3, so we have cosecant. Secant, what's this going to be when I flip it over and rationalize it?
3 square roots of 5 over 5.
And cotangent. Now, pay attention closely here. Which of these do you want to flip over?
The first one.
Okay. Square root of 5 over 2. If you flip this one over and rationalize it, you get 5 square roots of 5 over 10, which reduces to square root of 5 over 2. But it was much easier to just flip it over without the rationalized. Any questions? All right, still on 5A. These you should be doing without a calculator and without a unit circle. Somebody pick one.
21.
Number 21. Okay, pi is 180. What's 180 divided by 6? So this is a 30-degree angle. So if I draw a, that doesn't look 30. If I draw a 30-degree angle here, ooh, that was bad. Okay, what goes on this side over here?
1.
Square root of 3, 2. All right, these are all first quadrant angles, so all your answers are positive. No worries there. So cotangent, instead of opposite over adjacent, is adjacent over opposite, so we get part of the AP calculus test is no calculator. If you take AP Calc next year, the test is partially no calculator. So you have to know how to do these triangles without a calculator and without a unit circle in your hand. One more or not? Number, let's do one with a pi over 4. Number 20? Okay. What is a pi over 4? What's 180 cut in half and cut in half again? 45. So this is the tangent of 45 degrees, which is a 1, 1, and a square root of 2. Tangent is opposite over adjacent, so we get 1. Can handle those? All right. I'm still on 5A. 42 or 43, anybody have a preference? It just wants you to figure out what the angle has to be. So like on 42, if you do opposite over hypotenuse, anybody know which angle is across from the square root of 3? I didn't draw it right.
60.
It is the 60. So the answer here, because this is opposite over hypotenuse, so this is 60 degrees and wants both. 60 out of 180 is, yep, pi over 3. Or you can do 60 times pi divided by 180, right? Goes in there 3 times. If we did 45 real quick, cosine is adjacent over hypotenuse. What kind of an angle is that? Anybody know that one?
Which one?
It's a 45, and a 45 is pi over 4, yep. Is this coming back to you a little bit? Oh, you work on for a while, weren't you? All right, that's it on that page that you have to do. All right, so I covered examples for worksheet, I don't even know. What did I just do? 5A, okay. So circle 5A, you can now do 5A. I want to show you 8 real quick. I'm not even going to do it because they're so easy. This is worksheet 8. Worksheet 8B and 9A are the really easy stuff, like find the height of this church, given that it's a 60-degree angle and a 300 feet up here. It's just right triangle, pictures drawn even, most of them, okay?
Use tangent. Tan of 60 is equal to x.
Yep. Actually, on that one, you could just do 300 square roots of 3 if you wanted, because it's a 30, 60, 90. But yes, you're just doing right triangle trig on all these, okay? 9A and 9B.
What do you want us to round to?
You don't have to do anything on 9B, I lied. It's only 9A. 2 places? Can we go 2 places? Round to 2 places would be great. I'm flashing around here, I'm sorry. There we go. Any questions on 8 and 9? I think you'll be fine. All right, in that case, let's go to 6. Can you go to worksheet 6? Okay, don't kill me. This is worksheet 5B, it says. Is that right? Okay, 5B. I'm not going to read this to you. It says read this if you have any questions. This is 5B. Then there's 6A, which is also just, it does stress these definitions. Okay, make sure you look. All right, if you're needing those definitions for quadrantal angles. And other than that, I just want to do a couple examples. Here we go, 6B. Okay. What time are we done? Okay, because I'm gonna give you some time to work. But let me do a couple quick examples off here. The first one is a trick question. This is off 6B number 6, okay? This is my example. It says we went all the way around to here and the XY coordinate is 3 out on the X and -5 down on the Y. Everybody's first thought is that this is a 3, 4, 5 triangle.
No.
They're tricking you, right? Because the 5 is on the leg and so it doesn't work because the hypotenuse has to be longer than that leg. Everybody okay with that? So 3 squared plus -5 squared equals the hypotenuse or the radius squared if it's were a unit circle, which it's not, but
5 plus 9 is 34 square root of 34, and that's
doesn't rationalize. We're good. Or doesn't simplify, sorry. Square root of 34. All right. It says find all 6 trig functions. Sound familiar?
So why does number like the theta sign? Why is it just that? But is that
This should
theta means angle, right?
Yeah,
It's just-
this should
that's
really
all.
be a reference angle in here. I
Yeah,
should
right.
really use a different letter.
Okay.
Okay,
That was kinda
it doesn't
confusing.
matter.
I thought it was reference angle.
Okay. So the sine is opposite over hypotenuse, which when rationalized will become what? cosine is 3 over square root of 34, or 3 square roots of 34 over 34. Tangent is what?
Opposite over adjacent, which is -5 over 3.
Okay. Cosecant is flipping this guy over, so it's square root of 34 over -5, or negative square root of 34 over 5, doesn't matter. Secant is square root of 34 over 3. And cotangent is -3/5. Any questions on those kind? All right, still on worksheet 6B. Real quick, I got 2 more things to do and I'm done for today. Please be paying attention here. This question is another quadrantal angle, my example, and so is your problem on this, but if I go left 3 and up 0, what is the radius or the distance out to that point?
-3.
Okay, radius is always positive.
Oh,
Yep,
very much.
you're okay. But this is x and this is y. So if it wants all 6 trig functions again, really? Okay. We'd have the sine. That's why I signed like 1 of each of these. Okay, not like 1 through 12, because nobody wants to do all of them. Sine is y over r. So we get 0 over 3, which is what?
Undefined.
Nope.
Oh wait, no, that's 0. Never mind.
Okay. Okay, cosine is x over r, which is -3 over 3, which is tangent
Is undefined.
is y over x, which is
That's 0.
okay, when is it undefined, guys? Yes, when 0 is underneath. So this one is r over y, so it's 3 over 0, which is undefined.
Those ones are
Secant is 3 over -3, which is -1 still. And cotangent is -3 over 0, which is undefined. All right, better? Got to know those definitions. Last thing I'm going to do. Last thing today, and I'm done. When we are in the first quadrant, both the x and the y are positive, yes? X and y are both positive. So therefore, the sine, the cosine, and the tangent are all positive. We good? When we move over into quadrant 2, the x becomes negative. Well, which function has an x in it? Cosine. So the cosine is negative. The sine is y, so the sine is still positive. Tangent is y over x. What's a positive over a negative, guys? So the only one that was positive was the sine. Down in this quadrant, both x and y are negative. R is always positive, the distance out from here, okay? But if we have a negative here and a negative here and a, whoops, that one's an x. Okay, the cosine will be what? The sine will be, but what about the tangent? Tangent is y over x, or opposite over adjacent, so we get the tangent is positive. And what about over in this quadrant?
It's just above the quadrant 2.
This is a negative y. Well, which one deals with opposite or y? So the sine is negative. The cosine is x, which is positive. And the tangent? Tangent is y over x, or opposite over adjacent, so it is negative. All right, the way that most students have learned to remember this is all students take calculus. That means they are all positive in this quadrant. Only the sine is positive in this quadrant. Only the tangent is positive in this quadrant, and only the cosine is positive in this quadrant.
That means the opposites are.
All right? So that's what you need to know to do 14 and 15. I will finish the rest of worksheet 6B and 7, my examples there tomorrow, and then we'll go on and talk about angular and linear velocity. Okay, the other thing we have to do is a few simple trig identities. Do you remember, like cosine squared plus sine squared equals 1? Okay, they're not hard ones. We will do plenty of hard ones next semester. This semester you just need to know how to do some very basic ones before the final.